Hello guys, welcome back to my channel. Today I, Kishka Gupta, had brought an interesting topic of maths for you, that is integers. Introduction. We have studied whole numbers and the operations of addition, subtraction, multiplication and division on them. But we have not studied how to subtract a bigger number from a smaller number. Integers would tell you this. Let's find out. What is an integer? A set of whole numbers along with 0 and the negative numbers are known as integers. There are two types of integers. The first one is negative and the other is positive. Numbers before 0 are negative, like -1, -2, -3 and so on, and the numbers after 0 are positive, like 1, 2, 3, 4, etc. And they can also be written as +1, +2, +3, etc. So here's the number line, and the numbers to the left of 0 are negative and to the right of 0 is positive. So 0, we can say it is the midline. Now next is a boring but important topic, that is the properties of integers. There is no greatest or smallest integer, means they are infinite. Every integer has a successor as well as a predecessor. In whole numbers, every whole number do not have a predecessor, as 0 does not have a predecessor, but every integer will have a predecessor also. The number 0, it is also an integer, but it is neither positive nor negative. 0 is greater than every negative integer and less than every positive integer. 0, it is greater than every negative integer. If I put infinite zeros also, then also 0 will be greater, and it will be less than every positive integer, like 10, 100. How many zeros I put, it will be always less. So this is the 0 property. Now next is any positive integer is greater than any negative integer. Any positive number like 1, it will be greater than any negative integer. Greater than any negative integer. For example, I take 5. 1 will be greater. 50. 1 will be greater. And so on. If I put zeros and zeros, then only also 1 will be greater. An integer is greater than another integer if it lies to the right of the other on the number line. Let's see a number line to learn this. So an integer is greater than another integer because it lies to the right of it. 1 lies to the right of -1, so it is greater. So this is the property. Next is an integer is less than another integer if it lies to the left of the other on the number line. Let's look at the number line again. So here -3 is less than 2 as it lies to the left of 2, like this. So -3 is smaller. Next is the greater a number, the lesser its opposite. Like if we take 10, its opposite will be -10. If we take 20, its opposite will be minus 20. So the greater the number, the lesser its opposite. Means 20 is greater than 10. But here, minus 20 is less than 10. Next is, all integers can be represented by a point on the number line, but every point on the number line does not represent an integer. Let's see the number line again. Every integer, if we take 100, 1000, they all can be represented on a number line like this 5. But if I mark a point like this, just in the middle, anywhere, this is not compulsory that it will also represent an integer. This is not compulsory. This is the property. Now we'll learn integers on number line. In this I've told you how to make a number line for all the integers. We'll draw a line and mark 0 as any point on it, midpoint. Not any point but midpoint on it. Now we'll mark equal distances and write 1, 2, 3 on the right. We'll mark equal distances and write 1, 2, 3, etc. on the right, and minus 1, 2, 3 and so on the left. We can see that 1 and minus 1 are equidistant, means they have equal distance between them, and 0. Same as 2 and minus 2, 3 and minus 3 and so on. It is because of this property that all positive numbers, 0, and all negative numbers are called directed numbers or signed numbers. These all numbers are directed or signed numbers. Next is the absolute value of integers. What is absolute value? It is the numerical value without taking the sign into consideration. The symbol used to denote the absolute value is the two vertical lines, one on either side of an integer. For example, like minus 7, absolute value of it is 7, and of plus 7 is also 7. How? If we take minus 7, we'll put this minus 7 in these two lines. These are the vertical bars as shown here, and the answer will be the absolute value, that is 7. We'll remove the sign in this bars and take the number here. Now I take another number like 4. We can take plus 4. We'll put it in the bar line. This will remove the sign. And the answer will be 4. Next is addition of integers. To add any integer having same sign, we have to keep the same sign and add the absolute value of each number. For example, this is given minus 39 plus minus 69. So they both are having the same sign of minus. We'll put the same sign in the answer also. And now we'll find the absolute value. This is 39 and this next will be 61. So 39 plus 61 will be 100. And put the minus sign. So the answer is minus 100. And to add any integer with different signs, we have to keep the sign with the larger absolute value and subtract the smaller absolute value from the larger number. So here is an example, minus 45 and 26. We'll first find the absolute value of these two numbers. Minus 45 and 26 is already in its absolute value. But we'll just put the bars for our convenience. So here which number is bigger, 45 or 26? Obviously 45. So our answer that will also contain a minus sign. Now what we have to do, we have to not add, but we have to subtract these two numbers. So our answer 45 minus 26 will be 19, and our minus sign is also there, so minus 19. This will be our answer. Now this is a boring topic but very important, is properties of addition of integers. First is the closure property. Some properties are same as the properties of whole numbers that you have studied earlier. We'll learn the same in the integer properties. If a and b, there are any two integers, then a plus b will also be an integer. Like we take minus 15 plus 12 is equals to minus 3. So if we add them, then minus 3. This is the answer, and this is also an integer. So this is the closure property. Next is the commutative property. If a and b, there are any two integers, then a plus b, this will be equal to b plus a. For example, if we take 25 plus minus 18, if we add them, then we get 7. But if we reverse that, minus 18 plus 25, then also we'll get the same answer, that is 7. Third is associative property. A, B and C, there are any three integers, then A plus B in bracket plus C will be equal to A plus B plus C in bracket. And this also will be equal to, in bracket, A plus C, then add B to it. This will be also equal. Like we take, first we'll add minus 5 and 7, then if we add minus 12, this will be equal to, if we first add 7 and minus 12, then we'll add minus 5. And this also will be equal to, first we can add minus 5 plus minus 12, then we can add 7 to it. This will give the same answer, minus 10. Next is the property of 0. If a is any integer, then a plus 0 is equals to 0 plus a is equals to a. For example, minus 29 plus 0. This will be also equal to 0 plus minus 29, that will be minus 29. Here 0 plus minus 39, this will be also equal to minus 39 plus 0, that is minus 39. And there is an important point, that 0 is called the identity element for addition of integers. Why this is so? Because 0 does not change the identity of a number when it adds to it. So it is the identity element. The next is the additive inverse property. If a is in any integer, then minus a will be its additive inverse such that a plus minus a will be equal to 0. If a is any integer, then its opposite will be minus a. And if we add these two numbers, then we'll get 0. For example, 4. Its additive inverse will be minus 4. Then 4 plus minus 4 will be equal to 0. And one more example I can give, like if we take minus 3, its additive inverse will be 3. This will be equal to 0. This is the additive inverse property. Our last property is the existence of successor. If a is any integer, then a plus 1 is its successor. For example, minus 3 is the successor of minus 4. How? If we add 1 to minus 4, then we'll get minus 3. So minus 3 is its integer. So this is the existence of successor, because every integer has a successor. Now next is the subtraction of integers. The difference of any two integers is always an integer. This is the closure property. Remember? So with subtraction also it holds true the closure property. For example, if we take plus 7 minus plus 4, we can write it as 7 minus 4, that is equals to 3, which is also an integer. So it holds true for subtraction also. Now next was the commutative property. For any two different integers a and b, a minus b is not equal to b minus a. So commutative property does not hold true for subtraction. Now next was the associative property. For any three integers a, b and c, a minus b minus c is not equal to a minus b minus c, and is also not equal to a minus c minus b. So the associative property also does not hold true for subtraction. Next was the property of 0. For any integer a minus 0 is not compulsory to be equal to 0 minus a, and that is not equal to a. This is the property of 0. It also does not hold true for subtraction. Now here are some sums to solve. Let's start with our first sum, minus 100 plus 24. Now for different signs, we'll first find the absolute value of the numbers. So the first one is 100 and the second is 24. Now which one number has the bigger absolute value? Obviously 100. So our answer would also contain a minus sign, and now we'll subtract these two. We'll get the answer as 76 minus sign minus 76 is our answer. Next, 788 plus minus 21. Now if this type of question comes, now we have to remember the rules for multiplication as bracket is given. So when a different signs of plus and minus are given before and after a bracket, then always a minus sign wins. So we'll cut this plus sign. So 788 minus 21. This will be equal to 767. Next question. Minus 72 minus 27. Now for same signs minus before and after bracket, there is one more rule that with same sign it becomes plus. Minus becomes plus. So here minus 72 plus 27. This will be equal to, now here different signs again. For same rule we have followed here. Absolute value. For this absolute value will be 72. Minus will subtract these two numbers, and here absolute value will be 27. The greater absolute value is 72, its sign is minus, so minus in the answer, and if we subtract we'll get 45. So minus 45 will be our answer. Last, 98 minus plus 30. Now as I told in here, with minus plus before and after bracket, minus always wins. We'll cut this plus sign again, and it will be 98 minus 30. So our answer will come 68. So these are the answers. I hope you liked my video. Don't forget to subscribe my channel and like this video. Thank you for watching.